Let's record. And then as well, let's share the screen. Okay, so we're starting at May 2019, right? And it says the diagram below, and the guys, I sent all of you these questions, so you don't necessarily have to write them off. But if you want, that's fine too, because I had sent it to you guys for those persons who maybe can't get it printed, just to save you the time of having to write it off. So it says the diagram below shows, some persons are coming. All right, so the diagram below is showing the quadrilateral PQRS, and we know that it's a quadrilateral because it has 4 sides, right? So it's PQRS. Right, it says that PQ and SR are parallel to each other. They're telling us that's up here and here. They're telling us that SQ is 8, right? So if you notice, whenever I get these questions, what do I do before I even start going through? Many of our students, you guys don't start reading from up here. Consider it. You're supposed to start here. You know where you guys start reading your questions? Right here. So you just, length of PS. Suppose most times, not to say most, but sometimes they put very critical information in those little parts at the top, but because you guys don't want to read it, you guys end up missing out on some stuff, right? So you start reading your questions at the top, right? So break it to that habit to make sure that you're seeing all the pieces of information they've given you. So they told me it's the quadrilateral PQRS. I make sure that I'm seeing that PQRS. Awesome. Then I say, okay, PQ and SR are parallel. That's what I have in green. SQ is 8. Wonderful. They tell us that SPQ is 90. So that's right here. They told me that SQR is 82. That's right here. And then QSR is 30. So okay, no tricks in this question. Everything looks to be straightforward. Okay, so they're asking us to find the length of PS, right? And I'm realizing that PS is in the right angle triangle. All right, so we know that this is 8 centimeters. So we say, okay, how is this supposed to happen? I know from my right angle triangles, I'm always thinking about 2 things. I'm either thinking about Pythagoras theorem or my trig ratios, right? So for our right angled triangles, right? At this level, there are 2 things they're testing you for, right? Either for you to use Pythagoras theorem or for you to use the trig ratios. However, if I was going to use Pythagoras theorem, right? So let's say the x is at the PS. Right? So I'm going to tell you why we can't use Pythagoras theorem. So Pythagoras theorem says that the hypotenuse squared is equal to the sum sum of the other two sides squared. So yes, this would be 8 squared. Oh, no, it's not PS, so I want PQ. Sorry, I like the wrong one. Sorry guys, I was supposed to be here. PQ. Oh no, the first one is PS. Oh, I was looking at that one. I was wondering how anybody didn't correct me, you know. But also the access for the length of PS and PQ. Okay, let's go with PS first. Yeah, so okay, we're still good to go. All right, so we have PS squared plus PQ squared. And what I really want is a PS. But guess what, guys? I can't do this because PQ is also unknown. And there's no way for me to just look at the triangle and know what PQ is. So immediately I said, clearly, I'm not supposed to use Pythagoras Theorem. So I said, okay, well, maybe I'm supposed to use my trig ratios, or not even maybe. I can't use Pythagoras Theorem. I'm absolutely sure I'm supposed to use my trig ratios. So what is the missing piece of information? Well, I have the sides, but I know whenever I'm doing my trig ratios, I need an angle. So I wonder if there is something we know either about this angle or about this one. Right, guys? So what do we have? We have a vertical line meeting a horizontal line. So this is actually 90 degrees. Right? So angle PSR is equal to 90 degrees since a vertical line meets a horizontal line. And of course, if that part is 30, hopefully some of you can see that here will have to be 60 for the full thing to add to 90. All right, so I'm gonna go over it. So I'm just trying to walk you through because I know we didn't have class on Wednesday, so I feel like some of the information might be a little bit far. So I'm saying the first thing is that I realize PS is in my right angle triangle. I know that whenever I have my right angle triangle, there's two things they're testing me for. Either Pythagoras theorem or to use the trig ratios. Right, so we already established that it can't be Pythagoras theorem because we don't know what PQ is. So we'd end up being stuck. So instead I say, okay, let me use my trig ratios, but I'm saying that I would need an angle. And I'm saying that we should be able to see that here would be 60 degrees. Right, so you're going to label which one is your opposite, adjacent, hypotenuse, choose a ratio, and try to find PS. I'm gonna go through it with you, but you can go ahead and try. What do you think PS should be? Okay, so one person was able to get it. All right, I'm gonna go over it because I realized some of us maybe we've forgotten. Right, you have to be revising, right? It's not enough to just understand in class. You have to be revising outside of class. Okay, so let's label our sides and see. All right, we know that this is the hypotenuse that gives two sides. The one closest, the adjacent, the one across is the opposite. Right, so clearly what I'm working with. So I always want the side that has a measurement and then the missing side. All right, I'm going back to the SOHCAHTOA. So if we have adjacent and hypotenuse, it means we're going to use cos. So we have that cos 60, right, is equal to the adjacent over the hypotenuse. Right, so cos 60 is equal to PS over 8. And the 8, which is divided, and we take it across, we will multiply. Yep. And when you put cos 60 in, you'll get a half. Right? So PS is just 4 centimeters. So again, the main thing, so it wasn't a hard question, but what's the main thing you needed to take from this? One, okay, from a right angle triangle, I know it's either Pythagoras theorem or the trig ratios. We weren't able to use Pythagoras theorem, so we said, okay, trig ratios. We were able to see that the bottom part, even though they didn't give us with the right angle, right? We see a vertical line intersecting the horizontal. So we know that that was also 90. Right, and if this was horizontal, and they already told us that this is parallel, right? And in the same straight line that made a 90 at the top must make a 90 at the bottom. Right, so they're parallel, so we know they're going straight across. And then I'm saying if that same straight line made a 90 degree at the top, it has to make a 90 degree at the bottom. So you're trying to think what plus 30 gives us 90. That's how I have 60. So we now know that this side is 4 centimeters. Okay, can I get some yeses, some no's? So those persons who are good to go, give me yeses. Anybody not understanding, give me a no so that I can focus on you right now. Right, so if you're yes, fully understanding, everything is good, give me a yes. If there's anything unclear, let me know. Okay, guys, so those persons who are answering me, I'm giving me yeses. Now focus on them. I see one no, so I'll talk to that person shortly. Are there any other no's? Anybody else with a no? Anybody else needs to declare a no? Okay, yes, I'll repeat for you. For everybody else, go ahead and try PQ. For PQ, you can use either Pythagoras theorem or the trig ratios, completely up to you. Okay, so for the person who was late, right, just repeating, I'm saying you have this question and they ask you to find PS. Right? Let me erase it. They ask you to find PS, which I'm saying is in the right angle triangle. So I'm saying that whenever you have right angle triangles, right, at the CXC level, the only thing they're asking you at CSEC is either to use your Pythagoras theorem or your trig ratios. You know, once you see a right angle triangle, that's what you're being tested on. Right, so I was pointing out, even before putting in this angle, I was pointing out that we could not use Pythagoras theorem because for Pythagoras theorem, you need to know at least two of the sides. Right, so you need to know two sides. Right, but we only know one side, which is the 8. Right, so hence I know I can't use Pythagoras theorem. For the person who came late, are you seeing why you can't use Pythagoras theorem? Okay, awesome. Okay, so I'm saying then that leaves us, right, to do our trig ratio. But I'm saying that for the trig ratio, right, there has to be an angle involved, right? So need an angle. Whether you know the angle or you don't know the angle, but some angle has to be involved. So I said, okay, well, I wonder if I know anything about the angle right here or the one up here. The one up the top, we don't know anything about it. However, I was saying, because these lines are parallel, so look on the right side of the board. Because these lines are parallel, right? And I'm assuming they're horizontal. If this straight line up the top makes a 90 degree, right? Then it means that this one here also has to be 90 degrees. Right, I'm saying if I was supposed to think about it, I would say 30 plus what number gives me 90. So that's how I knew that inside here was 60. So basically I had everything. So I labeled the hypotenuse, the opposite, the adjacent. All right, so I'll work it over. So talk to me, are you okay with the labeling of the triangle in terms of why I have the opposite where I have it, adjacent where I have it, hypotenuse where I have it, all of that, okay? Okay, so I'm saying therefore I'm going to use cos. I'm going to say that cos 60 is the adjacent over the hypotenuse. So cos 60 is PS over 8. And I'm saying the 8 which is divided, let me take it across, we will multiply. Right, so you can either put it in your calculators all together or work out the cos 60 part. So the point is that you'll get 4. All right, so here is 4 centimeters. So those who just came in, you can take it off. Good afternoon. So for the others, I'm going to do it Pythagoras theorem way, and then I'm going to do it the trig ratios way so that you can see both. Okay, I'm not sure what you guys are doing wrong. There you go. All right, so we have P, Q, and S. We already said that here is 60. We know that here is 8. We know that this is 4. So I'm saying if you wanted to, you could use Pythagoras' theorem. So if I'm using, yes. All right, then we would have that 8 squared is equal to 4 squared plus PQ squared. Because remember, it's the hypotenuse squared is equal to the sum of the other two sides squared. So 64 is equal to 16 plus PQ squared. So the 16 is added. We take it across. We subtract. Right, so 48 is equal to PQ squared. There's still take note, because what if you get a question where you have to use Pythagoras theorem, right? So make sure that you know how to do it. And to get rid of the square, we have to square root. Right, so you should be getting 6.9 or 7. Yes, that's fine. Right, so that's doing it using Pythagoras' theorem. However, suppose somebody wanted to use the trig ratios instead. All right, this is the hypotenuse. This is the adjacent, and this is the opposite. So the two sides we'll be using. To be honest, you can use any side. You can use the adjacent and the opposite. You can use, so for sure we know we have to use opposite. So it's either opposite and adjacent or opposite and hypotenuse. Completely up to you. Right, so you could say that sine 60 is equal to the opposite over the hypotenuse. So sine 60 is equal to PQ over 8. So 8 times sine 60 is equal to PQ. Or, for those who wanted to use tan, you say tan 60 is the opposite over the adjacent. So tan 60 is PQ over 4. So 4 times tan 60 is equal to PQ. Right? And it doesn't matter which one. Overall, the answer is 6.9. Right? So all 3 options. Right? So there are 3 options to work part 2. All of them give you the same answer. Right? And this is your answer. Right, so we have 4, we have 7, You know that this is 60. That's the information we have. Give me some yeses, some no's. Are we all seeing that PQ is 7 or 6.9? Round it to the nearest whole number is 7, right? Are we all seeing part 2 of the question? Is there any no's? Now is the time to declare. Guys, if it's no, you just need to let me know and I'll go over it, you know, but if you're not saying anything, then I can't know what to help you. Okay, so one person not really getting the Pythagoras theorem ways. Okay, I'll help you with that because that's something you need to know in general. So whatever part of it you don't feel confident with, please let me know. Right, for everything else, guys, you need to, yeah, I'll go over it again, no problem. For the others, you seem to say yes, the area of PQRS, right? Then this is up to you. You can find the area of the trapezium or the area of the two triangles, right? Completely up to you. So it's either you're going to find the area. Those who want me to go over, just give me a second. Let me line these questions up. All right, so the area of the trapezium is a half A plus B times H, or we do the area of triangle PQS plus the area of triangle QSR. So for those who want to try, you can. Everybody else, I am gonna come back to you. Yeah, so going back to the part 2 of the question, right? It says you have the triangle. I'm saying there are 3 ways to work it. The first way is Pythagoras' theorem, right? And Pythagoras' theorem says, we'll go to another page. All right, we draw the scene. All right, and we've gone through this, guys. We have to revise. Right, so in general, Pythagoras' theorem says that a squared is equal to b squared plus c squared. Right, it's saying that the hypotenuse squared is equal to the sum of the other 2 sides squared. That's the rule. So when I get this, where this is 4, and this is 8, and of course, we know this is the hypotenuse. Right, we are saying that what 8 squared is equal to PQ squared plus 4 squared. Whether you want to, again, it doesn't matter which one you call B or C, you just can't switch where the A is, right? Because they're the one hypotenuse, but the other 2 sides doesn't matter. So then you say 64 is equal to PQ squared plus 16. So 64 minus 16 is equal to PQ squared. And then we said what, 48. right? So the 16, which is added, when you take it over, you subtract. When solving your equations, if you have a square, to get rid of it, you have to square root the opposite side. So for the person who asked me about the Pythagoras theorem, are you seeing it? Okay, so maybe you can tell that off. For the other person who asked me to go over it, are you seeing that option? Right, so then the other two options, since I wrote this on the other side, right? So for the other option now, I was saying that we have this triangle, right? And I'm saying that if you wanted to use, suppose you just want to use the opposite and the hypotenuse, right? Then that means you'd have to use sine. And then I'm saying that the 8, which is divided, when you take it across, you multiply. So you put that in a calculator and you're going to get 6.9. But suppose using that same triangle, let's do that side. Right, so we have the same thing about the hypotenuse, adjacent, the opposite. Right, but suppose instead you wanted to use the adjacent and the opposite. Right, I'm saying instead use tan. So you would say tan 60 is the opposite over the adjacent. So we'd say that tan 60 is PQ over 4. And I'm saying the 4 that's divided, when you take it across, so you don't have to do all 3 ways, guys. You just need to choose one. I am just showing you all 3 just for learning purposes. Right? But you would just need to choose one to do in the exam. But we don't know what the question is going to be, hence I'm just teaching you how to do everything. No, you don't use the sine rule to solve for PQ. And you don't do that because PQ is in a right angle triangle. So we don't use sine and cosine rule for right angle triangles. It's not that you absolutely can't, but that's not what they're testing you for at this level. You see, if it's whatever they're asking you for is in the right angle triangle, right. Okay. So the next part now, as I said, the area of PQRS. Right, so I'm gonna do it both ways. So the first thing is, let's use the area of the trapezium, right? Because I think we'd have almost everything. So let's go with the area of the trapezium. How do I know it's a trapezium? Right, because I have two parallel sides. Right, I mean, one side doesn't necessarily have to be straight, but this is what you want to be looking at, right? So this is really the trapezium. Right, so in general, for your trapezium, in the formula, the A and the B are the parallel sides, and the height is the vertical distance between them, right? So the A and the B are the parallel sides, and the H is the distance between the parallel sides. Right, so for Earth, right, we have P, Q, S, R. We know that this is 7. Right, we know that this is 7. We know that this is 4. But what are we noticing? We're noticing that we don't know SR. So I'd probably have to go and find SR. So no, because SR is in the non-right angle triangle, you know, you'll have to use the sine or the cosine rule. So for the person who was asking me about the sine rule, you don't use sine rule for PQ or PS because it's in the right angle. But yes, it does come into play for part 3. Right, so to complete my thing, so what I have so far is that the area would be a half 7 plus b times 4. So I don't know what the other side is. Right, so that's what I'm going to go ahead and find. Again, guys, even if you weren't planning to do it this way, it's useful to know what if you get a question where you have to do something with a trapezium. Okay, just giving persons a chance to write off. Right, so remember the general area is a half A plus B times H. Okay, if anybody needs me to go back, let me know. All right, so to find SR, let's see what we can use. All right, so now I'm focusing on QSR. Here is 82. This is 30, and we know that this is 8. Now, immediately I see 2 angles in the triangle. I know that I can find the missing angle to see if that helps me with anything, right? So we know that angles in a triangle comes to 180 degrees. So 180 degrees must be the 82 plus the 30 plus QRS. right? So 112 is for that. Right, so 180 minus 112. So again, guys, have to get comfortable with your solving. Right, so this is 68. So I can either look at all the information I have, and I'm either going to use the sine or the cosine rule. Already I know I can't use the cosine rule because for the cosine rule, I have to know at least two sides, right? So we're not using cosine rule since we need to know two sides. Right, so no cosine rule. But again, more important than that, you want to know why you're not using the cosine rule. I'm saying you're not using the cosine rule because for the cosine rule, you have to know two of the sides. That therefore leads us with having to use the sine rule. Again, giving persons a chance to write off. Guys, very quickly. But already I can tell you that for your sine rule, right? We know this side and the matching angle. And we know this angle and we want that side. So that's what we're using. In fact, I'm going to copy this instead. Again, if I'm switching the pages and you're not finished, just tell me to go back. I'm not in front of you guys, so I can't see how fast you guys are writing. All right, so essentially it's gonna be SR over sine 82 is equal to 8 over sine 68. All right, so SR over sine 82, let's put up my calculator. So 8 divided by sine 68 is 8.6283. Right, and then the sine 82, which is divided, when we take it across, we multiply. Right, which is giving us 8.544. Right, that's for SR. Since I did the others to 1, let's just put 8.5. Now guys, remember that we use the sine rule. Again, if anybody is still having a problem with the sine rule, guys, I have the videos in the folders. It's just for you to take your time and go through them. There is material there. Us trying to cram everything in the marathon, next to impossible. However, I am not leaving you high and dry. There's literally videos in the folder that you can use to learn these things slowly. All right, so we're gonna put everything together now that we know that this is 8.5. Let me see now the question that asks for the area. Remember, we had said that the area for the trapezium, right, was a half A plus B times H. So it's 7 plus 8.5 times 4. Right, so it should be 30.94, or if you're rounding it, 31. Right, so you should be getting 30.9 something, or based on how we're rounding, you could be getting 31 if we're saying to the nearest whole number. Okay. Give me yeses, give me no's. Is there anybody? So the yeses is just to keep you guys awake, but more importantly, those persons who are no's at this point, please let me know what's happening. If there's anybody that's a no at this point, please let me know what is happening. Okay, awesome. Okay, so what if we wanted to do two triangles instead, right? So for angle, for the area of triangle PQS, right? That's a right angle triangle. So the area is a half base times height. So you could do a half, 7 times 4. Right? So this would be 14. Yeah, so you multiply it by a half, right? Yes. So it's a half times, if you even want it. So it's a half times A plus B times H. So remember, whenever we see numbers on the outside like that, we know that they mean multiplication. So yes, you do multiply. So just like a half base times height really means a half times the base times the height. Right, and for this one, remember this area QSR now, that's a non-right angle triangle. So the area of that triangle is a half AB sine C. So let me erase everything just to remind us. Remember that if you want to find the area of a non-right angle triangle, you use one of the angles and the two sides making the angle. So it would be a half times 8 times 8.5 sine 30. Right, and we would get 17. Right, so the total would be 14 plus 17, which is the same 31. Right, so completely up to you, whichever one you would have wanted to use. Okay, so I await the questions for everybody else. I'm going to put the next question on the board. But if anybody has a question about the one from before, you just need to let me know. Right, if there's anything from the question before you're not comfortable with, let me know. Everybody else, asking us to state the type of triangle. That's the first part. What's the type of triangle? Okay, right? So what do we have? So no, definitely not equilateral. In a equilateral triangle, all the angles are 60. So it's definitely not equilateral. Right? But the person who said non-right angle, I mean, that is true, but not accurate. We wouldn't get the mark for it. Right? What they mean is like, is it isosceles? Is it scaling? I mean, if it was right angle, but that can't just say non-right angle. You have to say, yeah, that's fine. All right, so first of all, right, we have two equal angles. So for one, right, triangle M and P is an isosceles triangle, right? Since two angles are equal. All right, and we want to note if all angles equal 60 degrees, it would be a equilateral triangle. Right, because it will be 180 divided by 3, which is 60. Right, so no, it wouldn't be equilateral. And as I said, for the person who said non-right angle, not bad, but again, I don't think it would really get the marks because that's not what they're looking for, right? They want something a little more specific. Right, so we're going with isosceles since we see the two angles being the same. Okay, what about angle of P and M? Remember that's angles in a triangle sum to 180 degrees. So what's the missing angle? Yeah, I'm saying what's the missing angle? Part 2, it says what is angle P and M? Right, so for angle P and M, right, we know that angles in a triangle. come to 180 degrees. So 180 is equal to 52 plus 52 plus PNN. Right, so 104. So 104, which is added. I take it across, subtract. So it'll be 76. So no decimals. There's no need for any decimals. Right, so please note, because we know that it's an isosceles, right? The opposite sides are equal in the sense that this, even though they didn't say it, we know that this is also 12.5. Right, so because it is an isosceles triangle, it's not the ones that are beside, so some persons might put it here. No, so they are facing each other. All right, so we know that, and we know that this is 76. So guess what? We know the angle and we know the two sides making the angle. So you can find the area of the triangle. The area of the triangle is a half AB sine C, where C is the angle and A and B are the sides making the angle. Yes, so whenever you see letters beside each other, if there is no symbol in between, yes, it is a multiplication. So AB means A times B. So it's a half times A times B times the sine of the angle. right? So the area is a half AB sine C. So this is a half times 12.5 times 12.5 times 76. So yes, you guys should be getting 75.8. Yeah, so that question is pretty straightforward. Okay, seeing that the persons who tried got it. Very good job. Very good job, guys. My device was getting kicked off, so I couldn't respond to you guys. But if anybody's not okay with it, talk to me. You know, we should do this one first instead. Yeah, do this one instead. So, this is January 2015. So if there are any issues from anybody, please let me know. Right, the first thing is to do QS, and your hint is to use the cosine rule. Right, find QS. Right, so we wanted to make sure that we revise that before in the class, because as I said, today is going to be the last day for trig. Let's see how many other stuff we get through, and then we can always come back. Right, we want to get in some matrices and vectors. So a reminder how the cosine rule works. Right, remember that for the cosine rule, you need to be focusing on the side that you want, the angle across from it, right? And then the two sides making the angle. So we're going to use the cosine rule. If you don't remember, okay, part one, using the cosine rule to find QS. Right, so it's QS squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12. One more space. right? So QS squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 plus 16. So since I've set it out for you, go ahead and try to work it. Right, so it means that QS squared is equal to 81 plus 144. Hold on, let me just respond to some persons who are trained. Right, minus, so we have 2 times 9 times 12, so minus 216 plus 60. So QS squared plus 81 plus 144, so 225, and then 216 times cos 60 is 108. So QS squared is 117. All right, so the 2 times 9 times 12, that's all about 216. 216 times cos 60, that's all about 108. To get rid of the square, we have to square root. Yes, it should be 10.8. Right, to all the persons who answered me, that's what you got. It's a great job. For the others who are not responding to me, well, I cannot help you. If you do not let me know what is happening. So my advice, guys, if you need me to repeat, just simply let me know. All right, so we know that this is 10.8. So your hint for the second one, so this one, the first one was to use the cosine rule. The hint for the second one is to use the sine rule. All right, so since they want an QTS, all right, so see, I can line it out for you. So go ahead and try that. Okay, for the person asking me for the sine rule formula, because we're finding the angle, right? We have sine A over A, but the sine B over B. Right, so it's going to be the sine of what we want. So I'm just going to call it x. So it's going to be sine x over 10.8 is equal to sine 40 over 13. Doing some answers there, guys. We're having some calculator problems. Some of you, it seems you guys aren't afraid to try the questions, but the calculator or something. Sine 40 divided by 13 is going to give 0.049. Or I would say at least 4 decimal places. Right? So we're going to say that sine x is 0.0494 times 10.8. The sine x should be 0.534. And to get rid of the sine, right, you have to sine inverse the opposite side. So remember, guys, whenever we're finding angles, you have to use the sine inverse. So yeah, so it should be in the end 32.3. All right, so you're not going to get the person who told me that they got 0.05. First of all, you're not going to get an angle that's that small, right? So that alone should have said to you that maybe you did something wrong. All right, so just showing you how to look out for this. See, one person corrected it, very good. So again, guys, the angle, the sine of the angle over the side, sine of the angle over the side. If you guys are not getting the same thing, your calculator could be in the wrong mode. These are things you want to figure out the day. You want to figure it out before the exam, not the day of the exam. So when I did sine 40 divided by 13, I got 0.0494. Right? And the 10.8 is divided. When you take it across, we multiply. And the sine to get rid of it, we sine inverse. So to figure out this question, you really have to be using a calculator in order for it to make sense. All right, so the area of triangle QRS while I wait on questions. All right, it's a non-right angle triangle, so it's going to be a half AB sine C. I just need the angle and two sides making the angle. So it's a half times 9 times 12 times sine 60 Calculators, guys, calculators. And here is a half AB sine C. Okay, so it should be a half times 9 times 12 or 12 times 9, whichever one you prefer. So it should be 46.8. I'm not sure what happened at the calculator. No, why would you divide? Remember, AB means times. So it's a half times 9 times 12 times sine 60. Why would you divide? Are you seeing it? No, but you're never ever supposed to divide. The area is always multiplying. Yeah, so you shouldn't ever be lying, so I'm not sure. Okay, let's close off with this last bit. For May 2005, that missing question, I will send it to you. I'm also supposed to send you guys the rest of the solutions for functions. I'll put those two together. Send to you guys just with detailed explanations so that you guys can follow through. All right, so let's finish with the last one. It says they want the perpendicular distance from Q to RS, right? So the perpendicular distance from Q to RS. This question was a little bit tricky. Okay, so well, it's not drawn to scale, so your geometry set wouldn't help you. Because remember, it's not like it's accurate, so you wouldn't be asked to measure it. All right, we know that this is 60. We know that this is 9. We know that this is 12. So they're asking for the distance from Q to RS, but because they said perpendicular, what they're trying to say is that this line, right, makes a right angle with RS. So what they're asking for is the distance. If you notice, you're basically going to get a right angle triangle, right? So if I pull out what I want, I'm really going to focus on right? So let's focus on this little piece here. right? So what they're asking me for is that. Did you notice it was just 1 mark? So it wasn't supposed to be something difficult, right? They just want the distance. If you draw a straight line from the Q to the RS, but because it's a perpendicular, that was supposed to indicate Q perpendicular means forming right angles, forming 90 degrees. So you would say to yourself, okay, I'm gonna put in the right angle. This is the hypotenuse. This is the opposite. This is the adjacent. So the two sides we're working with, hypotenuse and opposite. So I'm going to write some next page, but I don't really want to turn. So we're going to say that sine 60 is the opposite over the hypotenuse. So sine 60 is x over 9. So 9 times sine 60 is what we're looking for. So you're going to get 7.8. Right, but the main thing is not so much the calculations, is for you to understand what it means when they're saying the perpendicular distance. Because if you couldn't draw it in, then you wouldn't be able to apply it, right? So that's really what you want to figure out. I guess, so once you're finished writing, you're free to go. However, if anybody else has any questions for me, feel free to go ahead and ask now. Let me just stop my recording.